4.2. In this lecture video, let's take a look at another power rule. All right. Again, this is a power rule. We just call them specifically power of a product. So what's going on now is for any real number a times b, whole thing raised into an outer exponent on the outside. So this is a times b, which is one term in the parenthesis. So I got one term in the parenthesis, and I have a parenthesis with the exponent on the outside. So we are supposed to multiply their exponents. So the difference between this power rule versus the previous one is now I have multiple factors inside my parentheses. Still one term, just multiple factors. So what do I do? Well, I still got to multiply the exponent. So my outer exponent now will multiply all the exponents, okay, that are on the top of each factor in the inside, or multiply all the exponents for all the bases that's in the inside the parenthesis. So n times 1 is n, so that means I should have a to the n power times b to the 1 times n is n. Okay, so this is another power rule. A lot of times I like to say like the outer exponent distribute its exponent or its power onto all the exponent in the inside. I use the word distribute so student can remember to multiply the exponents. Okay, before I continue, let's go back to 12.1. When the base are the same and the base are multiplying, we add the exponents. All right. When do I multiply the exponent? I multiply the exponent when I see a parenthesis, one term inside, there's an exponent on the outside. That's when I multiply. It's a lot like distribution, distributive property. Okay, if I got multiple terms that's in the inside, then I gotta use my 2 to do my distribution. Gotta bring all the terms to the outside the parenthesis. This is just like it, except we are multiplying the exponents. So once I multiply the exponents, as you can see, my parenthesis actually drops off, okay? So in a way, I'm kind of trying to bring my bases, okay, that were in the inside to the outside the parenthesis, okay? Same idea. All right, so very tricky when it comes to numerical value that is up front. Okay, let me show you this real quick. So I see a parenthesis. Okay, there's an exponent on the outside. All right, in the inside, there's only one term. Now, in the parenthesis, even though it's one term, I still got two different factors or two different bases. Okay, I'm going to purposely write it this way so you can see there is a base 3 or a factor 3 that has exponent 1. There's a base x or a factor x in the parenthesis with an exponent 3. So now my outer exponent 2 will multiply the exponent on top of the 3 and on top of the x. So coming out of the parenthesis, that should be 3 to the 1 times 2, which is 2, x to the 3 times 2, which is 6. So that will be 3 squared times x to the 6, and 3 squared is 9. So my final answer got to be 9 times x to the 6 power. Do this one right here. Parenthesis with an outer exponent on the outside. Inside the parenthesis, there's only one term. So I got two different factors here, or two different bases, okay, just within the parenthesis. The base 6 with the exponent 1, a base x with the exponent negative 2. So let my outer exponent negative 3 multiply all the exponents that are in the inside. So that's going to be 6 to the 1 times negative 3, which is negative 3 power, times x to the negative 2 times negative 3 is positive 6. So right now, these two factor or bases are on the numerator. Okay, purposely demonstrate this so you can see they are on the numerator over 1. And I see my base 6 has a negative exponent. So my base 6 got to be flipped to the other side of the fraction. Base x has a positive exponent, so that does not need to be flipped. So if base 6 flipped to the bottom, that becomes 6 to the positive 3 power. Okay? And this extra negative 6 got to stay on top. right? So remember now, back when we're talking about 0 and 1 for exponent back in 12.1, we said I keep on mentioning negative exponent does not make my answer negative. Negative exponent only give me answers that are between 0 and 1, which any decimal between 0 and 1 are proper fractions. So think about this. 6 to the third now is the denominator, which is 6 times 6 times 6, which is 216. X to the 6 on top. So that's my final answer. Now, if you bring up the calculator, how would you key in 6 to the negative 3 power? Well, I'm going to show you real quick, okay? 6 exponent is the carry key raised into a negative 3 power. It's going to give me 0 point something. See, that's exactly what I mentioned before. If I convert to a fraction, that will always be a proper fraction. 1 over 216. I did not write a 1 on top because I actually had an x to the 6 on top. That's why I just write x to the 6, okay? Rather than 1 times x to the 6 over 216. All right, so that's my answer. All right, so far we got 2 different versions of power rule. We got negative exponent rule. We got product rule where we add the exponents. All right, and we have quotient rule where we subtract the exponents. Okay, so in the next video, I will show you how another version of a power rule. Then we can put all the rules together in one problem and then work on those in a different video. All right, that will conclude this quick lecture video on the power rule, power of a product. Thank you for watching.